Welcome to Data Management and your first video. Today your video will be about the counting principles. There are two counting principles. The first one is the multiplicative counting principle. This one says if you have two or more tasks, such as flipping a coin and rolling a die, then the number of ways of performing both tasks can be found by multiplying the number of outcomes of each task. So, if the first of two or more tasks has m outcomes, and for each of these the second task has n outcomes, then together the tasks have m times n outcomes. The important thing in this case for the multiplicative counting principle is that the two tasks are done together. One way to determine from reading the question that the two tasks are done together is that they've used the word and. So if you are flipping a coin and rolling a die, there are 2 ways to flip a coin. There are 6 ways to roll a die. So 2 times 6 makes 12 ways in total to flip a coin and roll a die. Let's look at this example. If ice cream sundaes come in 5 flavors, with 4 possible toppings, how many different sundaes can be made with 1 flavor of ice cream and 1 topping? We'll start this by illustrating our answer with a tree diagram. When you make a tree diagram, it's important to define your two tasks. Our first task is choosing the flavor of ice cream. In this case, there are 5 different outcomes. So that is the value of m. The value of m determines how many branches there are in the first set. So because there are 5 different flavors, we will start with 5 branches. And then label each branch. So this is choosing chocolate ice cream, vanilla ice cream, strawberry, pistachio, and mint. So the first set of branches is for the first step, and the number of branches is the same as the number of outcomes. The second task is choosing which topping you would like. So that is task 2. And since there are 4 possible toppings, that is your value of n. So for 4 possible outcomes, on each of these branches, we are now going to add 4 branches on the second level. 1 for each type of topping. So we have chocolate, strawberry, butterscotch, and sprinkles. These 4 branches go on the bottom of each of the first initial 5 branches. And that's your tree diagram. So once again, for the second task, the number of branches is equal to the number of outcomes. And when drawing the tree diagrams, you have level 1, and you have level 2, and these levels represent the tasks. So if you have 3 tasks, you will have 3 levels of branches. Then each of these 20 points represents the final number of ways of performing task 1 and task 2. So chocolate ice cream, chocolate topping, chocolate ice cream, strawberry topping, chocolate ice cream, butterscotch topping, etc. Vanilla ice cream, chocolate topping, vanilla ice cream, strawberry topping, etc. By using the multiplicative counting principle, you could determine that there are 5 different flavors of ice cream, 4 different toppings, and that gives you a total of 20 ways to make a sundae. Here's an example that we'll try without drawing a tree diagram. How many possible outcomes are there if you roll a die and toss a coin? So in this case, task 1 is rolling a die, and there are 6 outcomes for rolling a die. Task 2 is tossing a coin, and there are 2 outcomes for tossing a coin. So the total number of outcomes is 6 times 2, which is equal to 12 outcomes. Once again, the key word to indicate that you are using the multiplicative principle is the word and. Let's take a look at another example. A coin is tossed 5 times. How many arrangements of heads and tails are possible? This time, since the coin is tossed 5 times, that means there are 5 tasks. 5 tasks instead of 2 tasks like there were in the previous 2 examples. Sometimes when we have questions with multiple tasks, I like to draw out little lines that represent each task. So this is coin 1 being tossed, this is coin 2 being tossed, this is coin 3, coin 4, and coin 5 being tossed. So for coin 1 could be heads or tails. So it could be heads or tails. So there are 2 possible outcomes. Coin 2 could also be heads or tails. So there are 2 possible outcomes. Same for coin 3, coin 4, coin 5. Each of them have 2 possible outcomes. Now this question doesn't specifically use the word and, but it is implied because if you are tossing a coin 5 times, you're tossing the first coin and the second coin and the third coin and the fourth coin and the fifth coin. So this is an and situation. Some of these and questions, all tasks have the same number of outcomes. That is an example of repeated multiplication. In which case, a short form, instead of writing 2 times 2 times 2 times 2 times 2, that's the same as writing 2 to the exponent 5, which would be 32 arrangements. For communication marks, make sure you are writing the answer to the question. How many arrangements? 32 arrangements. So if it's a repeated multiplication question and it works out to be an exponent, the base of the power represents the number of outcomes, and the exponent of the power represents the number of tasks. This is important so that you do 2 to the 5 and not 5 to the 2. We're now going to look at an interesting example of the multiplicative principle, and that is one of forming digits. Before we start the example, I just want to review that a 4-digit number ends in a ones digit, the second last digit is the tens digit, the third last digit is the hundreds, and the first digit is the thousands. Keep in mind for some questions, the first digit cannot be 0, because if the first digit was a 0, if the thousands was a 0, then it would only be a 3-digit number. And anytime it says the number must be odd, it just means that the ones digit has to be odd. So let's look at this example. How many 4-digit numbers are there using these numbers if you cannot repeat the digits? So in this case, it's a 4-digit number. That means there are 4 tasks to fill. You have to fill the thousands, the hundreds, the tens, and the ones. Now in this case, there are 1, 2, 3, 4, 5, 6 outcomes. That means there are 6 possible numbers that could go into the thousands place. So we have 6 outcomes to start. Now, once you have chosen a number to go in the thousands, and you cannot repeat the digits, that means in the hundreds position, now you only have 5 possibilities because you can't repeat the digits. So if you use the 7 for the thousands, you now can't use that for the hundreds. For the tens digit, now there's only 4 possible outcomes. And for the ones digit, there are 3 possible outcomes. And again, this is a hidden example of AND, because when you make a number, you're going to have a thousands digit and a hundreds digit and a tens digit and a ones digit. And this will work out to 360 numbers. Again, remember to add this for your communication marks. How many 4-digit odd numbers are there using these digits? So 4-digit odd numbers, that means there's 4 tasks. So we're going to start with our 4 place values. We have our thousands, our hundreds, our tens, and our ones. When answering these questions, you want to make sure that you do take into account any restrictions. So in this case, one restriction is that it must be odd. So if it must be odd, for an odd number, that just means that the ones place value has to be an odd number. So in the ones place value, it could only be the 5, the 7, or the 9. So the ones could only be the 5, the 7, or the 9. So there's only 3 possible outcomes that could go in the ones place value. The second restriction is that the thousands cannot be a 0. So the thousands digit cannot be a 0. So that means the thousands digit can be a 5, a 7, an 8, or a 9. So there are 4 possible outcomes that can go in the thousands digit. Note that in question 5, it's different than question 4. Question 4 says you cannot repeat the digits. Question 5 does not say you cannot repeat the digits. Those are our only 2 restrictions. So the ones digit must be odd. The thousands digit cannot be 0. After that, there's no restrictions. So the hundreds digit can be any of these 5. And the tens digit can be any of these 5. So once again, this is an implied AND. So that means there are 300 different numbers. So let's go to one of the hardest ones you're going to see. This time we're going to have a couple of different restrictions. We still have a 4-digit number. And our first restriction is that the thousands cannot be equal to 0. So that means the thousands digit can only be the 5, the 7, the 8, or the 9. So there's only 4 possible outcomes for the thousands digit. The second restriction is that the digits cannot repeat. Here's where we have a bit of an issue. So the first digit could not be 0, and you're not allowed to repeat it. So for the second digit, it can't be the same as the thousands. It can't be the same digit as the thousands, but now it can be the 0. So if the thousands digit was 7, let's say that the thousands digit was 7. That means the 7 is not available to be in the hundreds position, but now the 0 is available. So there are, again, 4 possible outcomes. And because repetition is not allowed, let's say that the 5 went into the hundreds position. Now there's only 3 possible outcomes for the tens digit. Let's say the 0 went into the tens digit. Now there's only 2 options available for the ones digit. So with your implied and, that means there are 96 different numbers. The second counting principle is the additive counting principle. In this case, it says if one mutually exclusive task has m outcomes and another has n outcomes, then the number of outcomes of either task is m plus n. If one non-mutually exclusive task has m outcomes and another has n outcomes, then the number of outcomes of either task is m plus n minus both. I'll explain this in a minute. In this case, the tasks are not done at the same time. The key word for the additive principle is or. So let me show you an example. Mutually exclusive means that there are no outcomes in common. So in a deck of cards, for instance, if you wanted to find out the number of hearts and the number of black cards, there are 13 hearts, there are 26 black cards, there are no cards that are hearts and black at the same time, so that means that M is 13, N is 26, so the number of ways of getting a heart card or a black card is 13 plus 26. In non-mutually exclusive, that means that there is an overlap between the two outcomes. So here's an example. Let's take a look at the number of ways you could draw a black card or a 10. There are 26 black cards, so that is your M. There are 4 10s, so that is your N. And in this case, there are 2 cards that are black and a 10. So that represents both. So if you think of it this way, the number of black cards fills this entire circle. The number of 10s fills this entire circle. That means the 2 cards that are both black and 10 have been counted twice. They got counted as black cards. They also got counted as 10s. They don't get to be counted twice. So that's why you're taking the number of black cards plus the number of tens, and you're subtracting the number that are both black and tens because they're not allowed to be counted twice, and that gives you a total of 28. Here's a couple of examples. How many ways can you draw a card that is a face or a 2? So, are these mutually exclusive? They are, because there is no way for a card to be a face card and a 2. So your Venn diagram would look like this. So in this case, your M is 12 because there are 12 face cards. Your N is 4 because there's 4 2s. So 12 face cards or 4 2s. That makes 16 ways that you could draw a face card or a 2. Question 8. How many ways can you draw a face card? So how many ways can you draw a card that is a face card or a spade? Is this an example of mutually exclusive? It is not, because it is possible for a card to be a face card and a spade. So your Venn diagram would look like this. We have face cards and we have spades. So your M is equal to 12 because there are 12 face cards. Your N is equal to 13 because there are 13 spades. But there are 3 cards that are both face cards and spades. So the 12 face cards covers all of this circle. The 13 spades covers all of this circle. So those 3 cards that are face cards and spades got counted twice. So we have the number of face cards plus the number of spades minus both. So that's your M plus N minus both. So that means there are 22 ways to draw a card that is a face card or a spade. One more type of example is one that combines and or in the same question. So a menu has 8 appetizers, 15 main courses, 6 desserts, and 12 beverages. How many ways can you select a main course, a beverage, and either an appetizer or a dessert? So you have a main course, a beverage, and either an appetizer or a dessert. So you have to decide where's your ands and where's your ors. Well, here you're going to have either an appetizer or a dessert. So your appetizer or a dessert. So there's going to be a plus in between an appetizer and a dessert. There are 6 desserts and 8 appetizers. There's an and here. So you're going to have a main course. Right here is an implied and, because you're going to have a main course and a beverage and either an appetizer or dessert. So there's 15 main courses, 12 beverages, and one of these 14 appetizers or desserts. And that makes 2,520 ways. So what I would like you to do is to pause the video and to try these questions at the bottom. When you're finished, come back to the video, press play, and check your answers. So please press pause now and try them, and then come back and check your answers. Okay, welcome back to the video. We'll check your answers. For question 1A, these are mutually exclusive events. So the number of multiples of 3 were 7. There were 2 multiples of 8, making a total of 9 ways. For question B, these were not mutually exclusive events. So there were 11 different multiples of 2, there were 7 different multiples of 3, and there were 3 numbers that were multiples of both. So that left 14 ways. Another way that this question could be answered, if you look at this Venn diagram here, there were 11 different multiples of 2, but in this section here, just in this section right here, if you take 11 and subtract these 3, you get 8. So there were 8 numbers that were only multiples of 2. This section here, there were 7 multiples of 3 in the whole circle. If you take away the 3 that were overlapped, that means there were 4 numbers that were only multiples of 3. And in the middle, there are 3 multiples of both. So there are 8 numbers that are only multiples of 2, there are 4 numbers that are only multiples of 3, and there are 3 numbers that are both. So another way that this question could be answered is multiple of 2 only plus multiple of both plus multiple of 3 only, and that also gives you 14 ways. So there's just 2 different ways of answering that question. Question 7, there were 2 different body styles, so that's your first level of branches. There were 5 different colors, and there were 3 different models. This is an and situation because you're going to have a body style and a color and a model, so that made 30 different cars. For question 3, this was a repeated multiplication question. You had 10 different tasks, each with the same number of outcomes. So each of them had 4 tasks. So if they all have the same number of outcomes, the base is the number of outcomes, the exponent is the number of tasks. For question 4, it was a 4-digit odd number. So if the number had to be odd, that meant that the last digit could only be a 3, a 5, or 9. So there were only 3 outcomes for the ones digit. If it's a 4-digit number, that means the first digit cannot be 0, and the first digit could also not be that last number because we're not allowed to repeat them. So there's only 5 possible outcomes. The hundreds digit, because there's no repetition, it can't be what you put in the first position, and it can't be what you put in the last position, but now it can be the 0, so there's 5 different options. And the tens digit is anything left over, so it can't be the first, it can't be the second, it can't be the last, so there were 4 options left, leaving 300 numbers. Question 5, you wanted a girl child and a boy child, so that's 15 ways. Number 2, you wanted the father or a girl child, so that's 4 different ways. Question 3 was non-mutually exclusive again. It's a female or a child. There's 4 females plus 8 children, but minus 3 that are both female and children. So that was 9 ways. If you did it the other method, there's only 1 female that is not a child. There are 5 children that are not females. So you could take the number of females that are not children, the number of both, and the number of children that are not females, and that also leaves you with 9 ways. That answer can be done in either one of these 2 ways. It's up to you. So that's the end of your first lesson. If there was anything here that you didn't understand, please make note of it and ask your teacher during the next class. Thanks. Bye-bye.